Canadian Lottery email draw Ontario 49 with this address. Attention winner, we're happy to announce to you the draw of a Canadian National Lottery in the UK Canada Online Sweepstakes International held this year. You've won $1 million. Your email ID was one of the ones that was selected. We will transfer the money to you. One of the reasons I put this problem on here is to think about, there's lots of scams out there that tell you you've won lots of money, but then they ask you eventually for information which would allow them to steal your identity or take money from you. So be skeptical of these. But suppose it were true. You decide to invest half of it in a CD, which doesn't allow you to take money out but gives you a fixed rate over a period of time which you agree to. So you put $500,000 in a CD with an interest rate of 5%, which means you're keeping 1.05% each year that it's in there, raised to the t. So that's your function. How much will it be worth in 5 years? Well, you plug in 5 for the number of years. That is 638,140.78 dollars. So you made some money on it over 5 years at 5%. When will it be worth $2 million? $2 million is equal to 500,000 times 1.05 to the t. Now another way to think of this is how long will it take for it to quadruple, to grow 4 times. So I divide this, that's 4, these divide out, and so I get 4 is equal to 1.05 to the t. And so how long will it take 1.05 to go to 4? So I can play around with some numbers. 1.05 raised to the 8, not even close. 1.05 raised to the 30. That's 4.32. 1.05 raised to the 35. Sorry, too high. 1.05 raised to the 25. 3.38. So it's between 25 and 30. We know that. To get more specific, I'll just keep climbing up. 1.05 raised to the 26 and see which one gets me closest to 4 without going over. 1.05 raised to the 27. 3.73. 1.05 raised to the 28. 392, that seems close. So 28 gives me 3.92. 1.05 raised to the 29. 4.11. So it's between 28 and 29 years. So now I'm going to start going through compound interest growth on this. And this is going to be a slightly new formula. And the idea here is, what if it were compounded semi-annually? Now let's talk about what this means. Compounding is this idea of how often they look in the account to make a decision on giving you interest. So for example, suppose I had $100 and it was 5% compounded annually, or simple interest. Well, this would give me, they look in the account once per year, give you 5% on it, and after the first year, you'd have 105. Okay, that sounds like money, so let's put that in, 105. And you can see in small amounts of money over 1 year, this might not make a huge difference, but keep your mind open to what if I kept doing this over the years. So $100 at 5%. What if it were compounded semi-annually, meaning twice a year? Well, they're not going to look in there and give you 5% and 5%. That would be just, that'd be like giving you more than 10%. But what they are going to do is look in twice a year and give you half the rate, so 2.5%. So they're going to look in once on the 100 and give you 2.5%, which means it's going to be 1.025. sorry, so $102.50. So not 102.5. And then they're going to look on 102.5 at the end of the year and give you another 2.5% on it, which would leave you 105.0625. Now this is just on compounding. It's not like they're changing your interest rate, but you'd get 6 cents more on $100. Imagine on $1,000 or $100,000, or imagine it over 20 years, how much of a difference that can make. Again, let's march the scenarios up. $100 at 5%. Quarterly, meaning 4 times per year. So this is now becoming tedious to do in the calculator, but you can imagine I'm doing a quarter of 5% is 1.25% do it 4 times a year. So the first time it would give me 101.25, and then times 1.125, so then I'd be at 102, and then times 1.0125, and then 103.79, and one more time 105.094. So now 9 cents more instead of 6 cents more. The frequency of compounding seems to be kicking in. Now, it'd be great if I had a formula for this, because this seems very tedious. And that is the amount I have is equal to the principal, the amount I put in originally, times 1 plus my rate over the number of compounds per year, all raised to the number of compounds times time. So this is where A equals amount after T years, P equals initial amount, which we often call the principal. That's why P, principal, P-A-L, I believe, principal. R is your rate as a decimal. N is number of compounds, number of times you look in the account per year. And T is time. So how would the equation change? Well, we didn't even write an equation for the first one. So the equation for the first one would be $500,000 times 1 plus my rate, 0.05, compounded once per year, times 1t. Now you notice that just looks like the simple interest when you simplify it, because it is. That's a annual compounding. But if you keep going to this problem, well, the equation changes because it's 500,000. The amount that I have is equal to that times 1 plus my rate, 0.05, compounded twice per year, raised to the 2t. How much money would you have in 5 years? So we're going to do a continual comparison of what do I have in 5 years. Before 5 years, I had $638,140. In this case, 500,000, 1 plus 0.05 divided by 2 in parentheses, and then close the parentheses, raised to the parentheses 10. So this would be 640,042.27, which is bigger than what we had originally by $2,000, the 638, almost $2,000. So just by this compounding thing, something that, you know, the bank isn't even advertising how often they compound stuff because people don't even ask about it, but it makes a difference. So this is our basis, and we're going to keep marching forward now with different compounding periods. Quarterly means 4 times per year, so this is 500,000 times 1 plus 0.05 over 4 raised to the 4t. And so in 5 years, calculating that out, 500,000, 1 plus 0.05 over 4 raised to the 4 times the 5. So we got to make sure we account for that 4 times 5. Plugging that into the calculator, get 241,018.62. So another 1,000 on top of the last scenario from semi-annually to quarterly. And now looking at monthly, 500,000 times 1 plus 0.05, 12 months in a year. And now checking out what that would mean for 5 years. I'm just going to change my 4 to a 12, and now it's 12 times 5, which is 60. So checking my parentheses here, making sure I'm closing everything. $641,679.34. So 641,679 compared to 641,018, still more money, 600 some bucks more, going from quarterly to monthly. And you can imagine we could go to daily. There is a continuous formula as well for compounding continuously. This works on population growth generally. Population grows continuously, although we will treat it as if it's not in this chapter. So hopefully that gives you a sense of compounding interest and how compounding matters, and you should maybe think about talking to your bank about their compounding methods. See if you can get a better compounding account.